Hi everyone, myself is Subramanian, working as Associate Professor in the Department of Pharmaceutical Chemistry, SNS College of Pharmacy and Health Sciences.
Aldol condensation reaction was discovered by Alexander Porphyrovich Borodin in 1872. He was the one who first observed the aldol formation, that is 3-hydroxybutanol from acetaldehyde in the presence of few crystals like zinc chloride or hydrochloric acid. Hi everyone, now we are going to discuss about the aldol condensation and crossed aldol condensation. So what is this aldol condensation? Actually, aldol condensation occurs in aldehydes having alpha hydrogen with a dilute base to give beta hydroxy aldehydes called aldols. That beta hydroxy aldehydes are called as aldols. This reaction is most commonly known as aldol condensation. If the condensation reaction occurs between two different carbonyl compounds, that is one is aldehyde, another one is ketone, means that type of reaction, that condensation reaction is called as crossed aldol condensation. Let us see the mechanism behind the aldol condensation reaction. It involves three steps. The step 1, that will be removal of acidic alpha hydrogen by a base hydroxide giving a reactive enolate, that is R1 C double bond O CH2 R2, that is ketone, which will react with the hydroxide group, will give enolate with the removal of water molecule, that is R1 C double bond O CH2 R2 plus OH, that will be present in a base. Okay, that base hydroxide and treatment with the ketone will give the enolate compound, that is R1 C double bond O CH R2. Enolate will be formed with the removal of water molecule. The step 2, that is the nucleophilic attack on the aldehyde at the electrophilic carbonyl C by the enolate in a nucleophilic addition reaction giving an intermediate alkoxide, that is enolate already formed here. There will be a nucleophilic attack on the aldehyde at electrophilic carbon of the enolate. So in a nucleophilic addition reaction giving a intermediate alkoxide compound, that is R1 C double bond O CHR2 plus R2 CHO, that is aldehyde. That intermediate enolate will, which will be reacting with the aldehyde, will give alkoxide, that is alkoxide will be formed R1 C double bond O CH2 C R1 R2 and R3. Okay, that is already we have denoted the enolate as R1 and R2, so aldehyde will be denoted as R3. So R1 C double bond O CHR2 plus R3 CHO, which will give R3 C double bond O CH2 COR2 and R3. Alkoxide will be formed in this reaction. The third step is the deprotonation of the water molecule, creating a hydroxide and a beta hydroxy ketone, that is the aldol will be formed. So from this alkoxide there will be deprotonation of the water. From the water molecule, that hydroxy group will be removed. Okay, that will give a beta hydroxy ketone compound. Let us see the reaction, that is R1 C double bond O CH2 CO R2 R3 plus HOH. So here hydrogen will be added to this alkoxide, which will give the aldol product, that is R1 C double bond O CH2 COH R2 R3, and this hydroxyl group will be eliminated. So which will give the beta hydroxy ketone, that is aldol will be formed in this reaction. Crossed aldol condensation can be elaborated as aldol condensation taking place between two different aldehydes or ketones. In simple words, when condensation is between two different carbonyl compounds, if it is two different carbonyl compounds, then it is called as crossed aldol condensation. If both contain the atoms of alpha hydrogen, then it will give out a mixture of four products. It is because both can form carbanions and can also act as a carbanion acceptors. This picture will tell the crossed aldol condensation. Here benzaldehyde on treatment with the acetone in presence of alkali such as sodium hydroxide will give the carbanion CH2 minus CO CH3. This CH2 minus CO CH3 again attack the benzaldehyde to give the intermediate, that is C6H5 CHOH CH2 CO CH3. Here water molecule will be eliminated from this intermediate, will give benzyl acetone, that is C6H5 CH double bond CH CO CH3. This is the example of the crossed aldol condensation. I hope you could understand the um, reactions of aldol condensation and crossed aldol condensation. Thank you.